Okay, think about the edge, like the absolute edge of everything we can see, the cosmic horizon.
Mm-hmm.
Now, what if that boundary? What if it isn't really the end? What if it's, I don't know, a doorway?
A doorway, too.
Yeah.
Something else entirely.
Yeah. Could our universe, this huge ancient thing we live in, could it actually be just one of many? Such a mind-bending question, right? It's right where science meets that basic human need to know what's next.
That curiosity is definitely powerful. And it's amazing how this idea, which used to be just, well, philosophy maybe, is now something physicists are seriously grappling with, using cosmology, quantum mechanics.
It really feels like it's exploded recently, doesn't it? Especially in pop culture.
Oh, absolutely.
You've got things like Everything Everywhere All at Once, which was just wild.
Fantastic film.
And the Doctor Strange movies, too. The multiverse is suddenly everywhere. It clearly hit a nerve.
It has, and sci-fi is, well, it's a great space to play with these big ideas, but, the concept isn't brand new. Think about Edgar Allan Poe, way back in 1848.
Poe? Really?
Yeah, writing about a limitless succession of universes, long before anyone was talking about big bangs or inflation. It shows how long we've been fascinated by, what else might be out there.
Huh. That's fascinating. So, okay, that's what we're diving into today, the science behind the multiverse idea.
Right, moving beyond the portals and the superheroes.
Exactly. We're looking at the actual theories, what different kinds are proposed, why do scientists even think they might exist, and, crucially, how would we ever prove it?
It's a huge challenge.
It sounds like total fantasy, I know.
Yeah.
But the reasons scientists are exploring this come from trying to solve some really fundamental puzzles about our own universe.
Precisely. It's all about pushing the limits of what we currently understand. So maybe we should start with the basics. When scientists talk about a multiverse, what do they actually mean?
Okay, yeah, good starting point. What is a multiverse, fundamentally?
Well, in simple terms, it's the idea that there might be other universes out there, beyond the one we can observe.
So not just, like, galaxies really far away in our own universe.
No, that's the key thing. It's the possibility of completely separate realities, different patches of space and time.
Our whole observable universe.
Yeah.
Just one piece of something much, much bigger.
Potentially, yeah. That our experience of space and time isn't the only game in town, so to speak.
Which, okay, leads to the really big question. Why? Why even entertain this idea? What's missing in our understanding of this universe that makes scientists think, maybe there's more?
That's exactly it. There are some features of our universe that are, well, a bit puzzling if you assume ours is the only one. Science journalist Tom Siegfried put it pretty well.
What did he say?
He said, basically, we cannot explain all the features of our universe if there's only one of them.
Okay. Like what kind of features? What are these cosmic head-scratchers?
Well, think about the fundamental constants, the strength and gravity, the charge of an electron, that sort of thing.
Right, the basic numbers that underpin physics.
Exactly. Why do they have the specific values they do? They seem very precisely tuned. And also, why has the universe been around for just the right amount of time for stars and planets to form?
And life to evolve.
And life to evolve. Why do stars shine the way they do? It all seems remarkably well suited for complexity for us.
Like we hit the cosmic jackpot. So Siegfried says there are two ways to look at this apparent luck.
Pretty much. Either. Option one. Our current theories are just incomplete. We need better physics, a deeper theory that will eventually show why these constants have to be the way they are.
Okay, that makes sense. Find the underlying reason.
Or option two, the more radical path.
Mm-hmm.
Maybe our universe isn't special. Maybe there's a huge number, maybe an infinite number of universes out there. Mm-hmm. And they all have different properties, different constants. And we naturally find ourselves living in one where the conditions are, well, comfortable enough for us to exist.
The comfortable universe idea. So we're here because this is one of the universes where beings like us could possibly evolve.
That's the thinking. It turns the fine-tuning problem from a question of incredible luck into almost a statistical inevitability if there are enough universes.
Okay, so that fine-tuning puzzle is a big motivator. Yeah. Let's get into the theories themselves then. How might these other universes actually come about? What are the main scientific ideas?
Right. One of the biggest ones comes from cosmology, specifically the theory of cosmic inflation.
Inflation. That's the idea that the universe expanded incredibly fast right up to the Big Bang.
Exactly. A tiny fraction of a second after the beginning, it underwent this period of exponential growth. And inflation theory has been really successful.
How so?
It explains a lot about the universe we see today, why it's so big, so uniform on large scales, the sort of patterns in the distribution of galaxies.
It solves a lot of cosmological problems.
It really does. Even though, as physicists like Andre Linde at Stanford have said, it felt a bit like science fiction when it was first proposed.
I can imagine.
Yeah.
So how does this super fast expansion lead to a multiverse?
Well, the key insight is that maybe inflation didn't happen just once, creating our universe and then stop.
Okay.
Maybe the process is eternal. Inflation stops in some regions, like the bubble that became our observable universe, but it continues raging in other regions of space, constantly spawning new bubbles.
Like a foam bath that just keeps making more bubbles.
That's a pretty good analogy, yeah. Each of these bubbles inflates rapidly, cools down, and becomes its own universe. A bubble universe.
And these other bubble universes?
Yeah.
Could they be different from ours?
That's the crucial part of this particular multiverse model. The level 2 multiverse, as it's sometimes called. Yes, the laws of physics, the fundamental constants, they might actually be different in each bubble.
Whoa. So gravity could be stronger or weaker. Electrons might have different masses.
Potentially, yes. The physics that emerges as each bubble cools down from the inflationary state could vary wildly. And these universes would exist, way beyond anything we could ever hope to see directly.
An infinite cosmic ocean, bubbling with universes with potentially alien laws of physics. That's quite a thought.
It's a staggering shift in perspective, definitely.
Okay, so that's the inflationary multiverse. What's another big contender? You mentioned quantum mechanics earlier.
Right, that's a completely different source for multiverse ideas. It comes from trying to interpret the weirdness of quantum mechanics itself, specifically the many worlds interpretation.
Ah, yes, the one that gets really strained with branching realities and stuff.
That's the one. Quantum mechanics tells us that at the smallest scales, particles can exist in multiple states at once, a superposition.
Like Schrodinger's cat being both alive and dead until you look.
Sort of, yeah. The many worlds idea, proposed by Hugh Everett III back in the 50s, says that when you do make a measurement, or when any quantum interaction forces a choice between possibilities.
Like whether a radioactive atom decays or not.
Exactly. Instead of one outcome being randomly chosen, the universe splits. Both outcomes happen, but in separate, parallel realities.
So every single quantum event happening constantly everywhere
is causing reality to branch. Yes, according to this interpretation.
Wow. So every decision I make, every random event creates another universe.
Effectively, yes. As physicist James Kakalios puts it, there could be an infinite number of parallel Earths. For every possibility, there's a reality where it happened.
So there's definitely a version of me who learned the banjo.
If that was ever a possibility based on quantum events or choices, then according to many worlds, yes. Somewhere, but you can't access that reality.
Right. These parallel Earths, they exist kind of alongside ours in dimensions we can't perceive.
That's the idea. They overlap, but are inaccessible. Max Tegmark calls this a level 3 multiverse. Same fundamental laws of physics, but different outcomes playing out in these endlessly branching timelines.
And didn't Lin have an example about this? Something about an atomic bomb?
Right. He mentioned that in some of these many worlds realities, perhaps the specific sequence of quantum events needed for the bomb to detonate just didn't happen that way. So in that branch, the bomb's a dud.
Okay, let's pause there. That's really different from the inflationary multiverse, isn't it?
Completely different mechanism, yes.
Inflationary level 2 gives you separate bubble universes, maybe with different fundamental physics.
Correct.
Many worlds, level 3, gives you branching realities within the same basic physics framework, just with different histories based on quantum outcomes.
Exactly. And as Lynn pointed out, in some of those level 2 inflationary universes, the physics might be so different that an atomic bomb wouldn't even be possible in principle. The rules would be wrong for it.
Got it. Two very distinct, very mind-bending concepts. Now, the question everyone probably wonders when they hear about this, if these other universes are out there, can we go there?
Ah, the sci-fi dream. Travel between multiverses.
Yeah.
Can we? Well, based on everything we currently understand about physics, the answer is almost certainly no.
Really? That definitive?
Pretty much. Tom Siegfried was quite blunt about it. He said something like, unless a whole lot of physics we know that's pretty solidly established is wrong, you can't travel to these multiverses.
So the barriers are just too immense, whether it's distance or different laws or...
Exactly. The sheer scale, the potential differences in fundamental rules, the possibility they exist in dimensions we can't access, our current physics just doesn't provide a way.
Siegfried did add a little escape clause, didn't he? something about the future.
He did, yes. He basically said, look, who knows what we might discover in, say, 1,000 years? Science evolves.
I'm not saying somebody can't figure out something that you would never have imagined.
Right. It's acknowledging that our current knowledge isn't the final word, but based on current knowledge, inter-universal travel is firmly off the table.
Okay, so no hopping between universes anytime soon. What about just evidence? Any proof at all? Can we see them, detect them somehow?
And that's the really big sticking point. Right now, no. There's no direct observational evidence. Zero.
So all these ideas, they're purely theoretical.
Primarily, yes. Theoretical predictions from frameworks like inflation and quantum mechanics, and also, as we talked about, driven by those philosophical questions about fine-tuning.
Right, that choice between our universe being a cosmic fluke, perfectly balanced for life,
or just one of many, where we happen to live in a life-friendly one.
it's a way to address that apparent coincidence. Kakalios called the bubble universe idea attractive for that reason, right?
Yes, because it offers a potential explanation for why our universe looks designed for us, without invoking actual design or unbelievable luck. If you have enough universes with different properties, one like ours is bound to show up eventually.
But the massive challenge remains. Is this even science if we can't test it? If these other universes are fundamentally unobservable?
That's a huge debate raging in physics and philosophy of science. Can a concept be scientific if it's not empirically testable, not falsifiable?
Where do people land on that?
Well, some argue no, if you can't test it, it's metaphysics, not physics.
Nah.
Others argue that maybe we just haven't figured out how to test it yet.
Like maybe there are indirect effects we could look for, or future experiments we haven't conceived of.
Possibly. Or maybe the theories that predict the multiverse, like inflation, can be tested in other ways within our own universe. If those broader theories get stronger and stronger support.
It lends some indirect weight to their multiverse predictions.
That's the argument some would make, yeah. It's not direct proof, but it builds confidence in the underlying framework.
So, bottom line, will we ever know for sure? Is this destined to remain speculation?
Honestly, we might never get that definitive smoking gun. That direct proof might just be impossible.
But the ideas themselves come from theories we can test.
Often, yes. Inflation makes other predictions we can check with the cosmic background radiation measurements, for example. Quantum mechanics is tested constantly in labs.
So strengthening those foundational theories might be the closest we get.
It could be. Or, there's always the chance of a completely unexpected discovery, something that just blows our current understanding wide open.
Like Siegfried said, the universe doesn't really care what we can or can't figure out how to test.
Exactly. His quote was great. The universe is not constrained by what some blobs of protoplasm on a tiny little planet can figure out or test. We don't know how to test it, and maybe someday we'll figure out how to test it, and maybe we won't. But the universe can do whatever it wants.
It's incredibly humbling, isn't it?
It really is.
Even without that solid proof, just thinking about the multiverse, it forces you to confront how limited our view might be.
Absolutely. It pushes the boundaries of what we even consider reality. Exploring these ideas, even theoretically, stretches our scientific imagination, our philosophical understanding.
And it really leaves you wondering, doesn't it? If our grasp on reality is potentially this incomplete, what else is out there? What other huge aspects of the cosmos are we just totally unaware of right now?
Maybe the multiverse is just scratching the surface. It's a fascinating, if unproven, possibility.
A truly deep dive into the unknown. Thanks for exploring this with me.
My pleasure. It's always fun to think about the big questions.